Okay, so there's the data then. Okay, so here are the numbers. So these are the ages. So I'm assuming this is 29 years of data, so I'm assuming only one Best Actor, right, each for the Academy Awards, okay? So for Best Actor, so over the last 29 years, these are the ages of all actors who have gotten the Academy Award for Best Actor. And so here, we want to find the 70th percentile. Okay, or P70, right? Okay, so that's what we want to find. So let's apply the formula, okay? So the formula is I equals K over 100 times N plus 1. Okay, so what is K? K in this instance is 70, right? So we're going to plug in for 70. So this is 70 divided by 100. So what? Basically, we're taking 70% of the data, right? It's the position 70%, right? So we're taking the proportion 70 over 100 times the sample size. So basically, we're saying what percentage of the data needs to be below, okay? So we're going to take the sample size. There's 29 observations. So we're going to add 1 to make 30. So this is going to be 30. So we're taking 70% of 30. Think of it that way. So if we take that, what do we get? We get excuse me, it'd be 21, right? So 21 is I. So what does that tell us? Remember, it's the position. It's how far up from lowest to greatest do we need to count to get to that percentile. Whatever data value that is, that's our percentile, okay? So if we count up to 21, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so 11, this is 22, right? So there's 11, I did that on purpose. So 11 and 11, 22, so that's number 22. So right here represents the 21st percentile, okay? So 64, so that means actors, so let's say so if an actor is 64, then that means he's in the 70th percentile, which means 70% of actors who have gotten the Best Actor Award for the Academy Awards has been at that age or younger. Okay, does that make sense? I hope that makes sense. Okay, so let's do another one. So let's say now for part B, we want to find the 83rd percentile. So let's do that. Okay, so let's do the 83rd percentile. So B, we want the 83rd percentile, or P83. Okay, P83. So now we're going to use the formula again. So I equals K over 100 times N plus 1, where K is now 83, right? So it's going to be 83 over 100. That's the proportion of what? 29 plus 1, which is 30, right? So now, what happens if we calculate this? Well, what are we going to get? Well, if you calculate this out, we don't get a whole number. So we get what? We get 24.9. Okay. So now, look at that, we don't get a whole number for I. So now what we're going to do is we're going to round up to 25, and we're going to round down to 24. And now we're going to find the values that are in both of those positions. So we're going to find the value in the 24th position and the 25th position, and then we're going to average them. So what's the 25th position? Well, this is 22, right? If we count 11, 22, 23, 24, there's one, 24, right? So let's circle this one. So this is 24. And then the 25th position is right here. So this would be 24th position, and this was the 25th position, right? So now what are we going to do with those two? We're going to average them. So what's the percentile then? Or what's the what value represents the 83rd percentile? It's going to be the average of these two, which is 71.5, right? So if we average these two, we get 71 plus 72 divided by 2, and we get 71.5. And so the 83rd percentile is represented by somebody who's 71 and a half years old. Okay? So again, that just demonstrates the two ways you're going to use this formula. In the case that you get a positive whole number or you don't get a positive whole number for I. Okay? So I hope that helps. If you have any questions, let me know, please. So I just want to do that. Now that's not the only thing we can do with percentiles. It's just one way. So I'm going to show you another formula here. Oh, let's see. Let's see here. Okay, so now let's take this same data set. So let me erase this, and we're going to now talk about going the other way, right? So here we said, okay, I want to know what value represents the 83rd percentile or the 70th percentile. But what if I give you a value, a data value, and I say, well, what percentile does that value represent? So this is like going the other direction, okay? So let me erase this, okay? So let's, same data set, and now let's look at this formula here. So now this is where now I'm given a data value. I'm going to pick an age. I'm going to pick a random age. And I want to say, hey, I want to know what percentile that age represents. So now here's where I'm going to use the definition of percentile I talked about. I'm going to find out basically what percentage of the data falls at or below that value. That's it. It's that easy. I just count up the number of values that are at or below that value, and then what? Divide by 100. Or excuse me, not 100. Divide by the sample size, right? I'm calculating a proportion, right? A percentile. I'm calculating the proportion of values that are equal to or less than the given value. That's it. That's the definition of a percentile, right? So we're going to use the definition to calculate it, right? So I'm going to count the number of values that are equal to or less than that value, and then find that proportion out of the sample size and multiply by 100 to turn into a percentage. Okay? So, here we go. And then you round to the nearest integer. So now, let's find, first of all, let's use this here. So to find the value, I'm going to define a couple of things. Okay? Let x equal the number of values in the data set that are less than the given value. Okay? And then let y equal the number of values in the data set equal to the given value. Okay? So x is the number of values in the data set less than the given value. And y is going to represent the number of values in the data set that are equal to the given value. Okay? So if we're, whatever the given value is, okay? So now, here's the formula, okay? So the formula to calculate the percentile, so we're going to calculate the percentile. How do I want to say? P sub or K. Yeah, I'll just say K. So right, so if I have the kth percentile, so K, equals, okay, so here's the definition. So all I'm going to do is I'm going to count the number, I'm going to take x, right? I'm counting the number of values that are below that value, and then I'm going to add the number of values that are equal to that value. But here's the thing. I'm not going to take all of the values and put them below because it's like I'm going to split the difference. So what I'm going to do is I'm going to take all of the values that are equal to the given value and I'm going to split it in half. So I'm only going to take half of the values in my count. Okay? So I'm going to take half of the numbers that are equal to. So I'm going to add 0.5 times y. And then what I'm going to do is I'm going to divide that by the sample size. Okay? And then I'm going to take that and multiply by 100%. Okay? Or not 100%, but 100 to make it into a percentile. Okay? So into k, right? So here's what I'm going to do. So let me rewrite that because I didn't give myself enough room. So here, I'm going to write it over here. So the kth percentile is equal to x plus 0.5 times y divided by n times 100. Okay, so that's going to be the formula. Do I have it on there? Yes, I do. Okay, good. I just don't know how much room I have for the, but it looks like I have plenty of room. Okay, so let's use this in this example here. So let's say I'm given the number 58, age 58, right? So now I'm going to use this formula and I'm going to find out, hey, what percentile does 58 represent in this data? Well, let's apply this formula. Okay, so I have 58. So here's the given number, right? So the given value, the given age, 58. Okay. So now, given this age, we're going to calculate the percentile that this age represents. So we're going to take k, and we're going to equal what? Well, how many values are below 58? Well, there's 58, so 58 is in here. So how many numbers are below that? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 values, right? So remember the formula. So let me write down the formula again. So x plus half of y, 0.5 times y divided by n times 100. Okay? So how many values are x? Well, that's going to be 18. And how many values are equal to 58? 1, right? Right there. So it's going to be half of 1, right? So it's going to be 0.5 times 1, which is just 0.5. And then we're going to divide by the sample size. Well, what's the sample size? 29. And then we're going to multiply by 100. Well, what does that equal? Well, we're going to get 18.5 on top, 29 on the bottom. So 18.5 divided by 29 times 100 equals 63.79. 63.79. Well, what do we do with that? Is that what the way we're going to read it is 60? It's a 63rd.79th percentile, and the answer is no. Okay, we're going to round up. Okay, we're going to round up to the next whole number. So this would be equal to the 64th percentile. So what percentile does the age 58 represent in this in this population, in this sample? It represents the 64th percentile. Okay. Let's do another one. Let's look at 25. Okay. So so we're going to do the same thing. Okay, so to find k, we're going to take x plus half of y divided by n times 100. Okay, so again, count how many values are less than 25. Well, where's 25? Right there. How many values are less than that? 3. By the way, remember, the data is ordered. You can't do this unless you first order the data. Remember that. So we have 3 plus 1/2 of y, which, how many 25s are there? 1. So again, it's just half of 1, which is a half, divided by n, which is again 29, times 100. And what do we get? Well, we get 3.5 divided by 29. Well, 3.5 divided by 29 times 100 equals 12.06. Well, what are we going to do in this case? Are we going to round up or down? In this case, we're going to round down. So we just used the regular rounding rules. I think I misspoke earlier. I think I said you round up. In that case, you're going to round up. Not in every case. You just do the regular rounding rules. So you're always going to round to the nearest whole number. So you're going to look at the tenths place and round up or down. Okay. So in the previous case, we had 63.7. Okay. Well, in that case, 7 is going to round up to 64. Okay. In this case, we got 12.06, so we're going to round down. So that's going to be 12. So it's going to be the 12th percentile. Okay? So I hope that makes sense. And if you have any questions, please don't hesitate to reach out to me. But I hope this makes a lot of sense with regard to using the formula and understanding what percentiles are and how to calculate them. Okay? So that's all I'm going to go over with percentiles, which is quite a bit. The next is related to percentiles, and if you understand percentiles, then the next one, which are quartiles, is going to make perfect sense. Okay. In fact, it's much easier to understand because we're dealing with much bigger partitions. Okay. So with percentiles, we were partitioning the data into 100 equal pieces. With quartiles, we're going to subdivide or partition the data into 4 equal parts. Okay, so that's the biggest difference. So if we talk about quartiles here, okay, let's look at a diagram. So let's take our curve, right? And now what we're going to do is we're going to divide into 4 equal parts, okay? So this here would be a quartile, right? So this would be a quartile. So this would represent 25% of the data. And then the next quartile would be 25% of the data, and so on and so forth. So we get 4 equal parts that each contain 25% of the data. So notice a couple of things, right? Let's compare this to percentiles, right? So look at here. If we look at this here, what percentage of the data falls below that? 50%. So this mark here is the 50th percentile, right? This here represents what percentile? Well, what percentage of the data falls to the left? 25%. So this is the 25th percentile. So this cutoff, whatever this value turns out to be, represents the 25th percentile. Well, what do you think this cutoff represents? Well, we've got to the left 75%. So that cutoff, whatever this value is, represents the 75th percentile. Okay? So let's see how quartiles correspond with percentiles. This here, we're going to call Q1. This is Q2, and this is Q3. So Q1 is what we call the lower quartile, okay? The lower quartile is also the 25th percentile, P25. So Q1 corresponds to P25, the 25th percentile. Now Q2 is called the middle quartile, or the 50th percentile, P50, or the median, right? It's also the median. Q3, if you guess, is called the upper quartile. So Q3 is the upper quartile, or the 75th percentile, okay? Or P75, right? Okay, so now, quartiles are very useful because we immediately can get information. Like, we know, hey, whatever these values are, we know, hey, between Q1 and Q3 represents the middle 50%, right? That's going to come up when we talk about box plots and things. So these numbers help us get some information about the distribution, okay? Again, bell-shaped and symmetric, okay? Doesn't have to be bell-shaped and symmetric to understand, as long as we partition the data into equal parts, right? 25%, 25%, and 25%, and 25%, okay? So now, let's talk about the interquartile range. So this is going to be important too. So the interquartile range is the range that represents the middle 50%. So let me use a different color here. So the middle 50% is from here to here. So this distance is the IQR, or what we call the interquartile range, okay? The interquartile range is just the distance from this value, Q3, to this value, Q1. So in other words, it's just Q3 minus Q1. Okay? So that's the IQR. Okay? So again, IQR equals Q3 minus Q1. Okay? And so it tells us the range of the middle 50%. That's it. The spread, or what you would call the spread too. What's the spread? You'll hear that used from time to time. What's the spread? It's the range. Okay, range and spread are used interchangeably. Okay, so now let's talk about outliers, because this gives us another aspect of outliers. Before, the last time we talked in the previous video, we said, okay, well, when we talk about standard deviations and we talk about outliers, what was the rule that we introduced? The one rule that's common is to say that, hey, if something is outside 2 standard deviations from the mean, or 3 standard deviations from the mean, but typically 2. If something falls outside of 2 standard deviations, we would call that an unusual value. May not be an outlier, but it would be an unusual value. If it's 3 standard deviations outside the mean, then that would be considered an outlier, a definite outlier. Okay? So we could use the rule 3 standard deviations, or if we understand quartiles, then we can also introduce another calculation that's common. Okay? So let's talk about that. Okay. And it uses the interquartile range in the calculation. Okay, now, here's the rule for outliers. Oh, I don't want to use that color. Let's use this. Okay, so outliers. Not that. Keep writing the same thing. Where's my editing? Okay. I almost did it again. Okay, outliers. Let's go talk about outliers again. So how do we calculate an outlier using quartiles? Okay, here's how we do it. If we use this formula, okay, we're going to take 1.5, that's the magic number, times the IQR. Okay? We're going to take that value and we're going to add it to Q3, and we're going to subtract it from Q1 to get 2 numbers. Okay? And those are going to come up later too. Okay? So here's the idea. We're going to take 1.5 times the IQR, okay? And then we're going to add to Q3 the upper quartile, right? And then we're going to take the same number and we're going to subtract it from Q1, the lower quartiles. We're going to take Q1 and we're going to subtract off 1.5 times the interquartile range. Okay? And so we're going to get a number for both of these formulas. Okay? This is going to give us the upper fence. Okay? So I'm going to call that the upper fence. And it'll make sense in a moment. But that's going to be the upper limit. Okay? Or the upper fence. This calculation will give us the lower fence. So what does that mean? It means any values that fall above this number or below this number are outliers. Okay? I hope that makes sense. So again, any values in the data set. So again, we calculate the IQR, right? We take the upper and lower quartiles, we subtract them, find out that range. And then what we do is we multiply the range, the IQR, by 1.5. And then what we're going to do is we're going to take that number, add it to Q3. That'll give us the upper fence, or upper limit. We're going to subtract that number from Q1. And that'll give us the lower fence or the lower limit. And then anything that falls outside those 2 fences are outliers. Okay? That's what we're going to do. Okay? Okay, so now, let's look at this example here. And again, you're going to want to order, well, you don't have to order the data in this case. Never mind. So here's what we're going to do. Okay. Let's do this. Let's use, oh, you know what? Let's use that data that we're, or you know what? Let's use this data. Let's use this data. This will be perfect. Okay. So let's use this data set. Okay. So I'm actually going to put everything together in one data set. So here's the thing. So here's the data set that I'm going to use. I'm going to use 1, 1, 2, 2. 4, 6, 6.8, 5. Okay, so let's talk about quartiles. Well, before we talk about the fences, right, outliers, let's talk about how do we calculate quartiles to begin with, right? Okay, great, I know what they mean, but how do you figure out what, how do I figure out what they are? I could use the percentiles, right? I could use the 25th percentile formula, how to calculate the 75th percentile, and then I've got them. But I could also use another method that works just as well, and it's related to medians. Okay, we know how to calculate the median, right? So here's a way you could do it. Again, it requires you ordering the data in order to do this. So here's how you find the quartiles of a data set. I've already got it ordered. So here's what I'm going to do. The first thing is I know that Q2 is the median, right? So I know how to calculate that. So let's find that first. Let's find Q2. Okay? What do? I order the data, which I have. Now I'm going to find the median, right? So how many values do I have in my data set? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's even. I just have to divide in 2 and then find my 2 middle terms and average them, right? So what did I have? I have 1, 2, 3, 4, 5, 6, 14. So 7. So I need to find my 7th position and my 8th position. So 1, 2, 3, 4, 5, 6, 7, and 8. So these two are going to be my what I'm going to use to find the median. So what's the median? Well, I'm going to average these two, right? So Q2 equals 68. Or excuse me, 6.8 plus 7.2 divided by 2. And so what do I get for my median? Q2? Well, what do I get? I'm going to get 7.0. Okay? That's my median. Okay? Notice that Q2 is not in the data set. Okay? Now, that's Q2, right? Now, how do I get Q1 and Q3? This is all you have to do, and it's really easy. We're going to split the data in half, and what we're going to do is we're going to find the median of the upper half and the median of the lower half. And the median of the upper half is Q3, and the median of the lower half is going to be Q1. So think about it. Remember, I'm partitioning the data into equal pieces, right? So what does the median do? It splits the data into 2 halves, right? 50% and 50%. Well, what am I going to do? I'm going to find the middle of the lower half and the middle of the upper half, and I've got it. So that's what we're going to do. Now the key to this, and because it's consistent with your calculator too, but it depends on the textbook. Some textbooks include the median in both the upper and the lower halves if it's part of the data set. Okay? Some textbooks exclude it from the upper and lower halves. Okay? In this textbook, which is what the calculator also does, because I'm going to show you, because your calculator gives you this to you as well, is that we're just going to exclude the median. If the median is in our data set, we're going to exclude it from our calculation of the median of the upper half and the lower half. So we're just going to exclude it. Okay? In this case, it doesn't matter because our median isn't even in there. But if it does, we're just going to take it out when we figure out what Q1 is and Q3 is. Okay? So here's what we're going to do. Now, let me use a different color. So now I'm going to find Q1, right? So what I'm going to do is I'm going to split the data into two halves. So one half is going to go this way, and one half is going to go this way. So I'm going to take the lower half, right? So the lower half is going to be these values. So what is the median of the lower half? Well, let's count. Well, I got 1, 2, 3, 4, 5, 6, 7 values. It's odd. So I just have to count to the middle, right? So what's the middle? Well, I've got 1, 2, 3, and that's the middle. So here is Q1. Now all I'm going to do is do the same thing with the upper half, right? So I've got 7 here, so I'm just going to count, or I can use the formula, right, to find the position, right? Well, I've got 7. Well, the formula says add 1 and divide by 2. So that gives me 4. So I just have to count to the 4th position, right? So 1, 2, 3, 4. There it is. So this is Q3. And I'm done. I've got all 3 of my quartiles, right? So now that's one step. So now we got that covered, right? So now, what about the IQR? Well, how do I calculate the IQR? Let's do that. So IQR equals Q3 minus Q1. Well, what's Q3? That's 9, and Q1 is 2. So what's my interquartile range? It's going to be 7. Okay? So far, so good? Okay. Now, what about outliers? Okay? How do we calculate the outliers? Let's see if there are any outliers. Well, we got to calculate our 2 fences. Let's do that. So, fence 1. Okay, so let's do the upper fence. Okay, the upper fence is going to be Q3 plus 1.5 times the IQR. Well, what does that equal? Well, Q3 is 9 plus 1.5 times 7, which is the IQR. Okay? So what does this equal? Well, 1.5 times 7 is 10.5, right? 10.5 plus 9 is 19.5. So our upper fence is going to be located at 19.5. Okay? Double check my work. So 1.5 times 7 is 7 plus 3.5, which is 10.5, plus 9 is 19.5. Okay? Now, what about the lower fence? Well, the lower fence is going to equal Q1 minus 1.5 times the IQR. Okay. And that's going to equal, what's Q1? 2. 2 minus 1.5 times the IQR, which is 7. Okay, so now this is still going to be the same number. This is going to be 10.5, or yes, 10.5. So now what we're going to do is we're going to take 2 and subtract off 10.5. Well, what's 10.5 minus 2? That's going to be negative 8.5. Okay, now, depending on the context of the problem, negative numbers may not make sense. If you talk about temperature, then it would make sense. We could talk about negative temperature. But if we're talking about weights of cows, then having a negative weight makes no sense. And in those cases, we would just cut it off at 0, okay? So, and in those cases, we wouldn't have any outliers because anything, well, not to say that any outliers. Let's see, weights of cows wouldn't make any sense either. Off the top of my head, I can't think of anything, but normally if negative numbers don't make sense, like areas, you know, negative area doesn't make any sense, we would just cut it off at 0, okay? So, and then we just leave it at 0, okay? So it depends on the context of the problem. But just suffice it just to go on just with the concept here, just so you understand. So what does this mean? It means that, hey, if I take all of my values, then I'm going to look at my values and see, are any of my values bigger than 19.5? Okay? If there are, then those are outliers, and I want to look at them and find out why they're outliers. It might be a measurement mistake. Okay? In that case, we throw them out. But if it's not a measurement mistake, we definitely want to look at it and see, okay, what happened here? Why did this occur? Okay? Then the lower fence says, okay, well, do we have any values that are less than this? If we do, those are also outliers. Okay? So that basically takes care of how do we calculate quartiles, how do we use the quartiles to get the IQR, and then use the IQR to find out what their upper and lower fences are to determine outliers. Okay, so there's another rule to calculate outliers. Okay? Okay, so let's move on. Let me see if there's anything else here that I want to cover. Okay, the last thing, and let's talk about the 5-number summary. Okay, so the 5-number summary has to do with box plots. So this is where we're going to get into constructing box plots. And again, all of these numbers that I'm going to calculating for you is spit out in your calculator. I'm going to refer back to my video that I did on calculating statistics using your calculator, using the TI-84, the TI-84 or 83 plus. Using the one stat variable function in your calculator. Remember, I said that your calculator gives you a whole bunch of statistics that we're going to use later. Well, these quartiles are some of the things your calculator will give you, okay? The 5-number summary is actually the last 5 numbers at the bottom when you scroll all the way down that your calculator gives you, okay? So the 5-number summary is the 5 numbers that we need in order to construct a box plot. And 3 of the numbers are the 3 quartiles. The other 2 numbers is the minimum and maximum values in your data set. Okay? So the 5-number summary. What's the 5-number summary? Exactly that. Oops. So a 5-number summary starts with min, the minimum value, Q1, Q2, Q3, and your maximum value. That's what we call the 5-number summary. And these 5 numbers is exactly what you need to construct the last graphical display that we're going to talk about, which is the box plot, which is used quite often in a lot of different contexts. Okay, so if we have these 5 things, then we can construct a box plot. And I'm going to use an example to show you. Okay, so in the last example, what did we find? Okay, now what we found, what was the maximum value in the data set? Okay, so I'm going to use that data set here. Okay, so the 5-number summary was, the minimum value was what? 1. Q1, what did we find Q1 to be? 2. Q2, or the median, right? This is, remember, the median. That was 7. And then Q3 was 9. And the maximum was 11.5. Okay? And notice that we didn't have any outliers in that data. Now this is how we're going to construct a box plot, okay? So all you have to do is take the 5-number summary and you're going to draw a horizontal line and you're going to write out the tick marks, okay? And you just want evenly spaced tick marks, right? So that's what I'm going to do. I'm just going to do evenly spaced tick marks. Okay, and so what I'm going to do is I'm just going to count out with tick marks. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and 12. Okay, and again, the scale depends on the context of the problem. I just did it by ones because I had enough room. So now, what I'm going to do is I'm going to take my 5-number summary and I'm going to plot it on the line with vertical bars. Okay, I'm going to show you how they look and why I do that. Okay, so all I'm going to do is at 1, I'm going to put a vertical bar. So I'm going to put the vertical bars first and then get out of the way so you can see it. Okay, and then let's see. Okay, so there are my bars, okay? So now, that's the first step, okay? So now here's how you construct it, because once you have those 4 vertical bars put on your number line, all you're going to do is create a box and whiskers, okay? That's hence the name, the box and whisker plot, or box plot for short. What we're going to do is we're going to take the minimum value, okay? Well, let me plot these just so you... So here's the minimum. So there's my min. There's Q1. Here's Q2, or the median. Here's Q3. And here's my maximum value, right? 11.5. Okay? So my bar is like in the middle of those 2 tick marks. Okay? So now what I'm going to do is I'm going to take Q1 and Q3 and I'm going to connect those lines with a horizontal line. Okay, so I'm going to go from here, I'm going to go from Q1 all the way to Q3. Okay, that's my box. Okay, now notice this box represents the middle 25%. Furthermore, I know automatically what percentage is in each part of the box, right? So I know this is going to be 25% of the data from here to here. And then I also know that 25% of the data is from here to here, right? Now, what am I going to do now? I'm going to connect the outside lines to the box with another horizontal line and make the whiskers. And so I'm going to go to the middle, from the middle of this line all the way to here. And I'm going to go to the middle of this line and all the way here. And I'm done. That's it. Now, I'm just using different colors to show you, but again, you don't use different colors, okay? So now, what do I also know? Well, I know from here to here is 25%, and from here to here is 25%, okay? So notice what I can get from this box plot. I can see that this is not symmetric data. This is skewed. In fact, it's skewed left or skewed negative. Look at that. It's skewed this way. As far as the middle 50%, the middle 50% is skewed, right? So look at this 50% here versus this 50%. So it's definitely skewed negative or to the left, right? This is the median. Look at the median, okay? Look at the whiskers. So I can see how the distribution looks as a box plot, right? So this is important, especially if I can have multiple box plots. What if I have another box plot up here? I can compare 2 different populations by looking at 2 different box plots. Let's think about gender, right? What if I was talking about an exam, right? SAT scores. What if I want to split up SAT scores by gender, and I wanted to compare how males do versus females? Well, I could put the two box plots on the same number line, right? Let's talk about SAT scores. I could put SAT scores on the vertical axis, or the horizontal axis rather, and then I could plot the box plots on both sides, and I can immediately compare the two by looking at the box plots, okay? So now also, what were the fences? Well, what were the fences here? Well, the upper fence was like 19 point something, right? So I could draw a fence out here by a dashed line, right? And then I could do a fence here for that fence. And then what would happen? What would happen if the maximum value, remember these values? What if my maximum value that I have in the data actually falls over here? What would I do then in constructing my box plot? Well, what you would do is I would not include that value as part of the whiskers. In fact, anything that goes past this, I would basically set aside, and I would not use those to represent the maximum or minimum value for the box plot. Okay? I would basically use the next highest number or the next lowest number and create my box plot. And then what would you do with the outliers? Well, you would denote them as an asterisk or a dot on the plot. So I would just basically have an asterisk out here.